Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the numericals which are based on analytical SHM and level 1 numericals. The analytical SHM is different from the physical SHM, in which some spring block system is oscillating and we have to find out the time period, or some pendulum is oscillating. That physical SHM is different from this analytical SHM. In this section, we'll be discussing the problems which are based on velocity, acceleration, energy, and the equation of SHM. So in the first question, you can see that there is a particle which executes simple harmonic motion with frequency nu. Then the frequency with which the kinetic energy of that particle will oscillate will be. So we know that the equation of SHM, x is equal to a sine omega t. If this is the equation of SHM, then velocity will be a omega cos omega t, and kinetic energy will be half m a square omega square cos square omega t. Now you can substitute this value of cos square, or you can see that the graph of the x displacement of the particle is sinusoidal like that, while the graph of kinetic energy would be the graph of cos square like that. And therefore you can see that if the time period of the SHM is t, then the kinetic energy is changing, and in fact this kinetic energy, this time is t by 4, this time is t by 2, this time is 3t by 4, and this time is t. So you can see that kinetic energy graph is repeating itself in the time of t by 2. So we can say that after each half time, each t by 2 time, the kinetic energy would repeat itself. Therefore, the time period of SHM of this kinetic energy will be t by 2 if the time period of SHM of the particle is t. Then we can say that the frequency of SHM of the kinetic energy would be double, because the time period of SHM of the kinetic energy became half, and therefore the frequency of SHM would become double. So the answer is 3, option number 3rd. And you can also write down this cos square omega t as 2 cos 2 omega t plus 1 by 2. So if you will write this cos square omega t like that, then you can see that the frequency of this function will be 2 omega, which is twice of the original frequency. So the correct option will be option number C. Now let's move on the next question. In this question, it is given that when two mutually perpendicular simple harmonic motions of same frequency and amplitude and phase are superimposed on each other. So we have already studied this topic as Lissajous figures, and I'll again remind you that in this case the first SHM is, let's suppose, a sine omega t, and the second SHM would be a, in fact this is in x-axis and this is in y-axis. So let us take it as x and this is y. So this y is equal to a sine omega t. You can see that the phase difference between both of these two SHM is 0, and they are in same phase. Their omega is same, frequency is same, and their amplitude is same. So you can see that x will be equal to y. So this is a straight line, which is the resultant motion of SHM, and therefore the correct answer would be option number 2. This is also called as Lissajous figure, and in this case the Lissajous figure would be a straight line, which is x is equal to y. Now we move on the next question. In this question, the motion of a particle is given by the equation x is equal to a sin omega t plus b cos omega t. So we have to find out that which option about its simple harmonic motion is correct. So first of all, we have to check that whether it is a simple harmonic motion or not. And we can easily see that this is a simple harmonic motion because it is a combination of two motions which have different amplitudes and which have a phase difference of pi by 2. You can see that this cos omega t has a phase difference of pi by 2 with sin omega t, and the amplitude of this motion is different. So you can directly add these SHMs by the method I have demonstrated already. So you can see that you can write down this cos omega t as, or you can assume this as x1 and this as x2. So x1 is equal to a sin omega t while x2 is equal to a cos omega t. In fact, b cos omega t. You can write down this cos omega t as sin omega t plus pi by 2, and therefore at t is equal to 0, if you draw the phasor diagram, then the phase of this sin omega t at t is equal to 0 is 0. So therefore the amplitude A would be drawn on the x-axis, because we will consider the phase as angle and amplitude as a vector magnitude. So the phase of this function at t is equal to 0 will be pi by 2, and therefore its representative is b. So b would be drawn on y-axis because it is pi by 2 ahead of a. So therefore the resultant amplitude would be r, and r would be equal to under root a square plus b square. So this is a simple harmonic motion, and I can also find out its equation. You can write down this tan phi as b upon a. This tan phi is equal to b upon a. So the resultant SHM would be equal to r, which is equal to under root a square plus b square sin omega t plus tan inverse b upon a. So this is the resultant SHM. So you can say that the time period, in fact the magnitude of resultant, amplitude of resultant SHM would be under root a square plus b square. So the correct option would be option number D. Now let's move on the next question. In this question, a simple harmonic motion is given by the equation y is equal to y1 plus y2, and I have assumed y1 as 5 sin 3 pi t and y2 as 5 root 3 cos 3 pi t. So this is y1 and y2. So we have to find out the SHM, the amplitude of the resultant SHM. So if we draw the phasor diagram, and we can write down this y2 as 5 root 3 sin 3 pi t plus pi by 2. So you can see that at t is equal to 0, the phase of this y1 is 0, and therefore its representative, which is its amplitude, would be drawn on x-axis like that. So this is 5, and the phase of this cos function will be pi by 2, so its representative 5 root 3 would be drawn like that. So this is 5 root 3. The resultant amplitude r will be equal to under root of 5 root 3 whole square plus 5 whole square. So this will be equal to 10, and this is y is in meters, so in centimeters this will be equal to 1000. So first of all we have to find out the amplitude. So the resultant amplitude will be equal to 1000 centimeters. So the answer is D. Now let's move on the next question. In this question, the equation of a SHM is given as x is equal to 10 sine 10 pi t, and we have to find out the distance between such 2 points where the speed of the particle would be 50 pi centimeters per second. It is given that x is in centimeters and t is in seconds. So let us first of all find out the speed function. So speed function could be calculated by dx by dt, and therefore it is equal to 10 into 10 pi cos 10 pi t. So it is equal to 100 pi cos 10 pi t. So let us first of all find out the time when, or the phase of that position where this speed would become 50 pi. So 50 pi will be equal to 100 pi cos 10 pi t. So you can see that cos 10 pi t is equal to 1 by 2, and therefore 10 pi t will be equal to pi by 3, because cos pi by 3 is equal to half. So this is the first equation. Now you can see that if we draw the motion of SHM, and this is positive extreme and this is negative extreme, and this is x is equal to 0. So at phase is equal to pi by 3, x will be equal to root 3a by 2. So at this position x, where x is equal to root 3a by 2, the velocity will be 50 pi, and the other position will be minus root 3a by 2, where the speed will be equal to 50 pi. So the distance between these two positions will be root 3a, and a is equal to 10. This is the amplitude. So root 3a will be equal to 17.32 centimeters. So the correct answer will be option number 3rd. Now we move on the next question. In this question, there is a mass m which is performing linear simple harmonic motion. Then we have to find out the correct graph which represents the relation of acceleration and the velocity. Now first of all, we know that the acceleration is equal to omega square x in SHM, and velocity is equal to omega under root a square minus x square. Now if we square both the sides, then this equation would be v square is equal to omega square into a square minus x square, and this is v square is equal to omega square a square minus omega square x square. Now you can see that this is a, and a square will be equal to omega square, in fact omega to the power 4 into x square. So a square by omega square will be equal to omega square x square. So we can substitute the value of this omega square x square here. So v square is equal to omega square a square minus a square by omega square. So you can see that this is y and this is x. So this y is proportional to minus x. So this would be a straight line, and this straight line would be having a negative slope. So the correct answer would be option number 2. Now let's move on the next question. In this question, the acceleration versus time graph of a object which is performing SHM is given in the figure. So you can see that we have to predict that which of the following kinetic energy graph would be the correct option. Now you can see this acceleration time graph is a graph of minus cos theta. So you can say that A is equal to A omega square into cos omega t, and this is also a negative sign. So if we have to find out the kinetic energy, we can integrate the acceleration to get the velocity. So integrating cos omega t will give sin omega t and with a negative sign. But we know that the kinetic energy is the function of v square. So if the velocity is the function of sin omega t, then the kinetic energy would be the function of sin square omega t. So the correct answer, I can say that the correct answer would be option number 1, because we all know the graph of sin omega t is like the option number 1. So the correct answer would be option number 1. Now let's move on the next question. In this question, it is given that the displacement of an object which is executing simple harmonic motion is given as x is equal to 2 into 10 raised to power minus 2 cos pi t meters. Now we have to find out the time in which its speed will become maximum for the first time. Now by watching this equation, you can see that this is an equation of cos, and therefore the initial phase of this SHM is pi by 2, which means that the particle has started its motion from extreme position and its speed will become maximum for the first time when it will pass through the mean position. So the time taken by the particle to move from extreme to mean position is t by 4, where capital T is the time period of the SHM. So in this case, you can see that if we compare this equation with cos omega t, then omega will be equal to pi, and this is omega, this omega is 2 pi by t. So cancelling this pi with pi, t will be equal to 2 seconds. This is the time period, but we have to find out the time in which the particle will move from A to mean position, and that time is t by 4. So t by 4 will be equal to 1 by 2 seconds. So the correct answer would be option number 1. Now let's move on the next question. In this question, the equation of SHM of a particle is given as x is equal to x naught cos omega t minus pi by 4, and the acceleration of the particle A is given as a cos omega t plus del. Now you can find out the acceleration by double differentiating the displacement. So dx by dt will be x naught omega minus sine omega t minus pi by 4, and this dx by dt is velocity. Now the acceleration A will be equal to dv by dt, and hence dv by dt is minus x naught omega square cos omega t minus pi by 4. So you can see that if we compare this with the equation given in this case, where A is equal to A cos omega t plus del, so you can see that first of all this amplitude of acceleration, which is the peak value of acceleration, is equal to x naught omega square. So the correct answer can be from option number 2, 3 and 4. And if we utilize this negative sign over here, then you can see that this acceleration can also be written as x naught omega square cos omega t plus 3 pi by 4. because we have added a phase of pi by utilizing this negative sign. So pi minus pi by 4 would be 3 pi by 4, and therefore if we compare this with del, then this 3 pi by 4 will be equivalent to del. So del is equal to 3 pi by 4. So the correct answer would be option number 4th. Now let's move on the next question. In this question, a function is given as x is equal to a sine square omega t plus b cos square omega t plus c sine omega t cos omega t. So we have to choose the correct options among 4 of them. So option number A says that this function would represent a SHM for any value of a and b and c except for c is equal to 0. So let us see that x is equal to a. This sine square omega t can be written as 1 minus cos 2 omega t by 2 plus this b cos square omega t can be written as 1 plus cos 2 omega t by 2, and this is c by 2 sine 2 omega t. So you can write this function as this one. So you can see that there are 3 functions of this is cos 2 omega t, this is cos 2 omega t, and this is sine 2 omega t. So there are 3 different SHMs which are combined together. So this combination is also a simple harmonic motion. But if c is 0 and if a is equal to b, then this function, this would be 0, and if a is equal to b, then you can see that a square would be common and sine square plus cos square would be 1. So this function would be only equal to x is equal to a square. So this would not a simple harmonic motion. So option number A is correct. Now for option number B, which says that a is equal to minus b and c is equal to 2b, then this motion would be a simple harmonic motion of amplitude root 2b. So let us substitute these values, that a can be written as minus b, so this is b, and cos square omega t minus sine square omega t plus c by 2 sine 2 omega t. So this function is cos 2 omega t, and therefore x can be written as b cos 2 omega t plus this is c by 2, where c is 2b, so b sine 2 omega t. So you can see that this is a combination of 2 different SHM which has a phase difference of pi by 2, and therefore the resultant SHM would have an amplitude of root 2b, which can be obtained by drawing the phase diagram. So this is b and this is b. So the resultant SHM would have an amplitude of root 2b. So option number B is also correct. Obviously for option number C, we have already discussed that if C is equal to 0 and A is equal to B, then this x would be equal to a square. So in fact A. So this is not a SHM, and if A is equal to B and C is equal to 2B, so if A is equal to B, then this sine square plus cos square would be 1, and C is equal to 2B, then you can substitute this value of C in this equation. So this is 2B, so this is B sine 2 omega t. So it would be also a SHM of amplitude B. Now let's move on the next question. In this question, we have to find out the potential energy of a simple harmonic oscillator when it is when the particle is situated at a distance of a by 2 from the mean position. So we know that the value of the velocity or speed in terms of omega and a is v is equal to omega under root a square minus x square, and the kinetic energy is equal to half mv square. So it is half m omega square a square minus x square. So this is the kinetic energy, and the potential energy is equal to half kx square, where k will be equal to m omega square, and this is x square. Now at x is equal to plus minus a by 2, there at that point potential energy is half m omega square a square by 4, and this is, if we write down the total energy as half m omega square a square, then this potential energy will be equal to E by 4. So the correct answer would be option number 3. Now let's move on the next question. In this question, you can see that a particle is executing simple harmonic motion, and it has a kinetic energy k that is equal to k naught cos square omega t. So we have to find out the maximum value of kinetic energy, as in fact the maximum value of potential energy and the total energy of the motion. We all know that the total energy of the motion is equal to the maximum potential energy, as well as it is equal to the maximum kinetic energy. So we can say that the maximum kinetic energy in this case is k naught, and therefore this is the total energy and this is the maximum potential energy. So the value of maximum potential energy and the total energy of the motion is the option number 1, which is k naught and k naught. Now let's move on the next question. In this question, a particle is performing SHM with amplitude equal to 10 centimeters. So we have to find out the distance from the mean position, where the kinetic energy of the particle is thrice the potential energy of the particle. So we know that the formula for kinetic energy in terms of displacement x is half m omega square into a square minus x square, and the formula of potential energy in terms of displacement x is half m omega square x square. So we have to find out the value of x for which the kinetic energy is thrice equal to the potential energy. So kinetic energy is equal to 3 times of the potential energy, and this is half m omega square into a square minus x square, and that is equal to 3 times of half m omega square x square. So cancelling this half m omega square, then you can see that this is a square and it is equal to 4x square, and x is equal to plus minus a by 2, which means that a is equal to 10 and therefore x is equal to plus minus 5. So this is the correct answer. Now this was the complete package which was based on the numericals based on analytical SHM, and this was the level 1 numericals. And in the next video, just coming after this video, I would be bringing the level 2 numericals which are based on analytical SHM. And I can say that this level 1 numericals are important as far as JEE mains and Neet are concerned, or BitSat is concerned, while level 2 numericals is important for JEE advanced. So we'll discuss the level 2 numericals in the next video. Thank you.